This is Ranger Kidwell-Ross, editor at WorldSweeper.com, director of the World Sweeping Association. Today, we are going to be speaking to one of the directors of Global Environmental, one of the leading sweeper manufacturers in the United States, and Sebastian Mentelski. And Sebastian will tell us all about Global, really. One of the companies you may or may not know all about already, but my guess is you don't know all about them because they have a very fascinating product line and well as how they have progressed in the industry. So with that, let me say, Sebastian, welcome, and talk to us however you would like about Global and what you're up to these days.
Oh, Ranger, thank you very much for your introduction. Obviously, like you said, we're a company that we're located in California. One of the things we specialize in is specifically building purpose-built chassis. So all of our street sweepers, I would say, are built on our chassis, whether it's a Global M3 or a Global M4, and that gives us the ability to build them in with CNG technology. It gives us the ability to make changes to the chassis to make it more suitable for a hybrid fuel cell or hybrid technology, fuel cell technology, CNG, and obviously electric. Obviously, one of our major design ideas is to develop that chassis to make it fit and make it do whatever we want it to do and grow with market needs, I suppose.
Well, I know one of the things that purpose-built chassis brings you, and I go all the way back to Athey Mobile, which is one of the most revered products that's ever been in the industry in terms of beefiness and so forth. But the chassis is made for sweeping, and that's what you can say about your chassis is it's designed specifically for operator reliability, comfort, and so forth in the application of sweeping.
Absolutely, that's exactly what we do. So everything starting from the frame and how the frame is designed and how much load we can carry to essentially something we call minimization. So if you look at our sweepers, even our class 7 trucks themselves, we have a very, very short wheelbase, which is truly important because it gives the guys a 18-foot turning radius on them force versus any other truck that'll do a 26 to 30 feet. So it gives us the ability for a big truck, class 7 chassis, to be able to sweep around cul-de-sacs. We designed the machine so the overall profile of the sweeper is not too tall, so you don't have to worry about trees and tree limbs. We're constantly developing the cab to make sure that it's designed around one operator specifically, but it's comfortable, it's big enough. And then we also try to work in ways of reducing maintenance and unforeseen issues. So I think we're the only manufacturer. We don't use air to control any of our functions. And as we know, air is very problematic. Airlines get older, they crack, they leak. You have to worry about air compressors and everything else. We don't do that. We do disc brakes, wet disc brake systems, and we try to keep the machines as simple as possible. And now with 2023, we have a lot of technology available to us, so we are focusing on ease of use. We are focusing on essentially lower maintenance and finding ways to finding ways to how I could say is to make the machine as minimal as possible and as easy to fix as possible.
Mm-hmm. You said that you have a presentation that just kind of lays out what you're doing there. Do you want to show us some of those slides?
Absolutely. Yep. So I'm gonna kind of run through here. Give me 1 second.
And one of the things you're really known for is early on electric adoption, the first hydrogen adoption. You talked about fuel cells already, CNG, alternative fuels. You really have been known for looking to the future and being a kind of a leader in technology, I would say, among the machines. And That's very admirable feature to have.
We started looking into the EV platform or the electrification almost a decade ago, I would say, in 2011. And one of the first things we started playing with was it was a basic hybrid technology and capacitors. So we literally started working with capacitors before EV batteries were available. And the initial interest was to harvest some of the energy from the street sweeper and from the engine itself, and just find a way to use it, and find a way to make the machine a bit more efficient and reduce the emissions and NOx and pretty much everything else. And that was our curiosity. When we built the platform, we then started to learn about some of the things and some of the issues that we would have to overcome. Being that you have to write a software. How do you drive the machine? How do you make sure everything is properly powered and you have all these safety systems in place? And how do you work on serviceability of the batteries and the motors and everything else? So just to kind of finalize it, we did start quite a long time ago, and I think that's what this presentation is about. Just kind of showing you a bit of evolution of that product and not just all the products that we did.
Okay. Sounds good.
So I wanted to kind of talk about alternative fuel options that are available today. As you know, and you've mentioned that we have been working with CNG for quite a long time. One of the cool things that we were able to do with our purpose-built chassis at the time, even going back quite a long time, we were always able to extend our chassis about 26 inches, move our cab forward, and put the CNG tanks behind the cab without ever affecting the turning radius and the wheelbase, which is really cool because I believe we were always one of the only manufacturers who could build a CNG sweeper and with the same turning radius and everybody, as a regular diesel machine. We never made the truck bigger. We never made the truck longer. So again, that's something that we've always been proud of is when we are approaching our when we're building and we're looking at these products, one of the things we're trying to do is to make sure that our core competencies haven't changed. You want to have an easy product to maintain, to service. You want to have the lowest total cost of operation, and you obviously want this thing to be maneuverable and to do a really good job for you. So with CNG, obviously we were able to do that. Now, the hybrid technology, like I said earlier, was no different. Our initial design was putting a generator on an engine. We didn't have batteries back then, so we used capacitors to give us short burst of energy to be able to manage that energy and kind of see how it would, how we could deploy it to save money. But even our initial hybrid sweepers, they already had electric motors. So we had a generator that would be hooked up to an engine. The engine would run as much as it needed to create enough power to to the capacitors, and then we would use an electric motor to drive the machine and to essentially operate the unit. In 2018 is when we started working on fuel cell, and we had an opportunity to build a fuel cell sweeper for one of our biggest customers, California DOT, and we did so. And when we started doing that, at the same time, we essentially felt that we were ready to build electric street sweepers at the same time. So that's how we kind of rolled into this. I still believe HEVs are great. I think when it comes to, I believe that when it comes to customers being able to find, I would say, a stepping stone between a diesel and electric battery sweepers, HEVs or hybrid sweepers definitely have their purpose. We do offer two types of HEVs. One is our very standard model, I would say, which is really, really efficient too. And what it does is essentially it's got a generator that when you start the engine runs all the time and it charges the batteries. And then obviously we take the power from the batteries and we move them to the drive system, and then we've got another motor that runs all of your hydraulics. That is our basic concept. It's a very, very good machine, very reliable. And then the second machine we have just unveiled, and we started that just went into production at the end of 2022, and that's a plug-in hybrid. which is very similar. The differences are that in a plug-in hybrid, you're able to charge the battery when the machine is essentially, you can plug it in at the end of the shift and you can charge it. And the machine can actually run on battery itself for roughly about 45 minutes without the engine at all. And then as soon as the battery is depleted, the engine starts and it starts recharging the battery, and obviously it keeps on sweeping. So
And with hybrids,
hybrids are
Sebastian, what's the fuel consumption like? Is that reduced? Or you said the diesel's running all the time, but it's not probably running as
correct.
many RPMs
So,
and so forth.
so
So are there gains?
correct. So with a standard hybrid, we see roughly about a 50% emission, a 50% reduction in fuel. So a standard hybrid, when you start the machine, with a standard hybrid, when you start the sweeper, the engine runs the whole time. Okay, so it'll run between 1100 to 1600 RPM. All depends obviously on the power requirements and how much we need to charge the battery. But on that system, we're about 50. We're a bit more efficient on the plug-in side, because on the plug-in side, the engine runs and charges the batteries, but as soon as the batteries are full, it automatically shuts off.
Okay.
For a couple hours during that shift, that engine isn't operating at all, and the machine is just essentially running at its own pace on batteries themselves.
Gotcha.
So that obviously is a bit more efficient.
Sure. Okay.
So a little bit more expensive than a standard hybrid, but it's something that seems to be gaining more and more traction. And obviously, it's it obviously also it helps many cities in terms of applying for grants. A lot of grants require not just a hybrid, but they require a hybrid with a plug-in option.
Ah, okay.
So that's where things get a little bit complicated. Here I have on this presentation, I have a little bit of a just kind of like a roadmap. The first global M4 hybrid was literally designed in 2007 as a global. When we took over the company global in 2011, that's when we started combining large generator and batteries. Okay, so we went away from capacitors and we started literally focusing on the battery technology and just looking what we can get out of them. Now, back at that time, batteries were very rudimentary. They were not very complicated. They were very big, and you could not get a lot of life out of them, but it was still a good way for us to test the limits of the motors, how to be efficient driving the sweepers, and how to be efficient driving the sweep gear. So this is probably the biggest thing that we found. When you look at every other competitor, it's very easy to stack a lot of batteries on top of each other to get your 8 hours or 9 hours or a whole shift on a machine. But the problem is, the more batteries you stack on, the heavier the sweeper becomes and the less efficient it becomes. Okay, then you're compromising. Then you have to beef up your chassis. You have to make your chassis longer. You have all kinds of things you have to do. So one of the things we wanted to do is we wanted to find that number where we can put just enough batteries on the sweeper itself that'll give us that shift, but don't change the overall machine itself in size. You don't have to increase the weight substantially, and that's essentially been our goal. Okay, so even if you look at our 2023 global M3s and M4s, we are only using 210 kilowatt batteries, and the machine literally weighs $1,000 more compared to a regular diesel. And when it comes to an M3, we definitely can push 8 to 9 hours of sweeping easily, still leaving the operator with 20% of battery life left at the end of the shift, so they can wash the machine and do everything else.
And how long does it take to recharge that machine? Then will it
So
recharge sufficiently overnight?
So yes, so we actually our initial machines were only sold with level 2 charging systems. We felt that if we were to go to a municipality and tell them, hey, you have to buy a machine, that's honestly a double of a diesel, and then you still have to bring in your DC station and cables and everything into that. That's going to be impossible for us to sell and for customers to be able to accept this technology. So we designed a system that allows us to use Clipper Creek station. You plug it into your wall at 240 volts system with 80 watts. or 100 amp fuse in the system, that gives you about 11 to 12 hour charging capacity with 240 volts.
Mm-hmm.
Yeah, so still not the best, because we found a lot of customers, they run these machines and now they want to run them 2 shifts, and so it still doesn't check all the boxes. But that was essentially our first rudimentary system. So we told the customers, hey, you'll buy the sweeper and then we'll give you the charger. All you do is you have to mount it, and you don't have to worry about the DC stuff and everything else until, later date. But this first machine is going to do just that. That was the whole idea.
Mm-hmm.
So, but just coming back real quickly to the presentation, we delivered the hybrid sweepers to New York City. Obviously, New York City, everybody knows they've been our biggest partner when it comes to sweeping and testing this equipment. And in 2018 is when we designed the fuel cell zero emission street sweeper for California DOT, and then that was designed essentially for long-term testing and seeing how viable, feasible fuel cell technology is going to be, how realistic it's going to be to actually be on the road, because the discussion always is, and Ranger, this, are we going to stay with batteries or are we going to go to fuel cell?
Right.
Is it going to be what kind of matrix are we going to use to measure what we do? And we believe at Global that it's not going to be all electric or fuel cell. It is going to be a combination, and some things are going to be fuel cell because that's where a better fit, and some things are going to be electric.
Mhm. And fuel cell is more expensive than electric, would you say?
I would say not really. I would say it's about the same.
Is it? Okay.
Depending on the size of the fuel cell motor and what you're trying to accomplish. I don't think it's that much more expensive.
And can you speak? So we've had 5 years of testing by Caltrans. What do they think? What do you think so far?
You know what? Just the fuel infrastructure has been the only issue that we've had so far.
Uh-huh. Okay.
Managing the fuel cell hasn't been difficult. Keeping it clean hasn't been difficult. Cooling hasn't been a problem. We've addressed quite a few issues, and don't get me wrong, we've learned a lot from the project. But having the fueling infrastructure to be able to fuel that machine fairly quickly has been a problem. Most of the fueling stations in California have been designed for cars.
Yeah.
So it's short bursts of fuel cell, not for something that can hold 50 or 60 gallons equivalent of fuel. So one of the biggest issues we've had is a lot of fueling stations. Um, Hydrogen fuel stations have been down for maintenance,
Hmm.
and maintenance procedures take a long time, or they've had problems, and so you have this thing where you think there's a fuel station you're running to, and then it turns out that the fueling station isn't actually open.
Not there. Yeah. Right.
Yeah.
Okay.
So I think the infrastructure is going to be the problem, not the technology itself.
Mhm. Okay.
So, and then finally, the only thing I want to say is in 2022, I'm happy to say is we build a three-wheel electric sweepers. We can build them in hybrid as well, the two versions of the hybrid. We are building an M4 rear dump and a high side dump in hybrid and electric as well. And we're just finalizing now all the air machines, R3 and the R4. We're in the middle of testing and finalizing if that platform can sustain that system as well. We're not ready there. We're still testing, but we're close.
And can you, or is this a good time to talk about the grant program that is out there now for electrics? Is that something that people are able to find oftentimes grants that will help them buy the newer technology like this?
Yeah, you know what? It is. It does depend on cities and municipalities in the state and how available the money is. Our first go around, we've noticed a lot of VW money that was dispersed throughout the states, that was available to a lot of cities. Essentially, it essentially saying that if a city is buying a street sweeper, the VW money would pay for 100 to 110% of the difference in cost.
Mm-hmm.
And so a lot of cities that we had worked with utilized that grant. We work extensively with Clean Cities as well.
Sure.
And Clean Cities has been able to help us And we also work with fleet as well. But I'll be honest with you, every single state that I know has different grant requirements and programs, and it does
That
depend on
makes
the
it
state.
so hard, right?
Yeah,
We
it
need
makes
a
it hard.
unified federal grant program to go with that. And my understanding is the Infrastructure Act may kick in with that a little ways down the line, but we'll see how that part works.
That's what we are hoping for on the infrastructure side, is that not only does it allow cities to buy the EV technology, but there has to be money for the DC charging stations. You have to have money for the infrastructure.
Yeah.
So this year, we decided that every single sweeper that we build is going to have the capability of charging using the 240 volt system that I mentioned earlier. But we're also building every single machine that they can actually do a fast charge as well. And we are hoping that as the cities buy these machines, that they do get the fast chargers, because I truly do believe, and I think most of the team will agree, that unless you have a DC fast charging station, it's still something that you're nervous about. So just to give you an idea, it takes us 11 hours to charge the machine using a 240 volt system. It'll take us less than two
Oh
with
boy,
an 80
what a difference.
kilowatt station. Yes,
Yeah.
exactly. Yeah, so if it takes you 2 to 3 hours to charge a machine, now all of a sudden you can, sweep and do two shifts. Now all of a sudden you can drive back to the shop and hook it up for 45 minutes during lunch, and it gives you 20-30%. It takes away any kind of anxiety that you have in terms of all that electrification.
Hmm.
And it just kind of takes a lot of things off the table.
Yeah. Okay.
So that's what I'm hoping that Infrastructure Act is going to do, is just not only focus on the equipment itself, but the infrastructure. You need the infrastructure if you want to grow your fleet on the electric side.
Well, early on, that was certainly and to some extent still is with CNG. That was the issue. Is it LPG? Is it CNG? Can depend on what your infrastructure is, or do you have to stay with diesel? And I know Southern California and California in general is really upping its game when it's with diesel engines. Doesn't want them anymore. And
Mhm.
I have reported that Isuzu will not be trying to meet the diesel requirements of California starting with its 2024 models, which means the start of 2025, really, realistically. So that gives people a little bit of time, but that shows what we're really looking at, folks, is uh,
Mhm.
is electric is going to is really coming to the fore, and then fuel cell after that and so forth. So anyway, go ahead.
No, absolutely. Yeah, you're absolutely right. The technology is becoming available. Everybody's investing in it heavily, so we're going to see it everywhere. I've got a presentation here, just a little bit of a slide shows you on, how we design the system. So it kind of gives you the idea. We have a generator that is hooked up right into the engine, and then we've got another motor that essentially all it does is when it starts, it runs all of our hydraulics. And essentially we try to keep these machines as simple as we possibly can. Um, um like you had said earlier, we're all trying to reduce the carbon footprint.
Yeah.
And so that's the thing. We can talk about noise pollution, which is huge as well. But whether it's a fuel cell or it's batteries, both of these vehicles use electric motors, so people don't understand that it's all electricity at the end of the day.
Hmm.
um and the only thing I want to discuss is just same thing. When it comes to hybrid and electric, I do believe that unless you have a grant that is available that can pay for everything, and electric is a stretch. You're talking paying upwards of $700,000 for an electric street sweeper. And so one of the cool things that we've been discussing is you can still reduce your emissions by 50% or so if you buy a hybrid machine, and that step isn't that much. Now you're talking roughly 600,000, $550,000 for a machine, depending on the model, versus 800. And so that still gives the ability for a city to fund something like this themselves rather than going out for a grant. So we don't want to, I believe, discount the hybrid technology at all, because it is I think a great way to build up to that electric technology. Not everybody can afford that.
Have you learned in terms of longevity yet? Have they been around long enough to know whether the longevity of a electric sweeper is better? We know that CNG typically has more longevity available because the engines work longer. At least that's, correct me if I'm wrong on that. But how about with the electric technology? Does that keep a sweeper on the road longer, do you think?
Yeah, you know what? So I don't have the data here with me, but I can tell you that uh, based on a lot of research that we've done, we had found on average the machines, the electric sweepers are on the road 11% more compared to a diesel unit. So if you look at a diesel sweeper, you not only have to maintain it, you have to make sure your sweeping components are working and everything else. But the second, probably most expensive part of it is fuel and maintenance on that engine. So every 250 hours to 500 hours, you have to change your fuel filters, hydraulic, you have to change your engine oil. Yeah, and then you obviously have DEF. We also have DEF issues. And so there's a little bit of downtime associated with that. On average, what we see is about 11 to 14% of downtime on a Cummins engine. And it's not downtime because the engine's broken. It's just you have to you have to do your service. The machine has to get in the shop. You have to change the engine oil. You have to change the filters. You have to do proper maintenance, and that's got costs associated with it and mechanics time and everything else. On an electric sweeper, that all goes away.
So when you talk
Okay.
about the say 11% of time that doesn't have to be spent, how about the money part? Uh, do you have any handle on how much less it costs to maintain the EV sweeper than the diesel? It seems like that's another aspect. It's not only your time, but it's
It
the
is, it
cost
is, it is.
cost of
We have some numbers internally. The difficult part is to put a real number on it because you've got, how can I say this? You've got your average diesel fuel prices, but as you know, diesel fuel cost is completely different in California than it is, let's say, in Iowa. So it's hard for us to maintain that. It also does depend on the usage. So the machines are designed to operate for 10,000 hours, but we have customers that usually operate them for 5 to 700 hours. And then we've got some other customers that operate them between 750 to 1,500 hours, 2 shifts. So you have to be able to manage both and then see where you're at. I can tell you that, we're still not there. So I can't comfortably tell you that after 10 years there's a return on investment. We still have to invest in this stuff. The cost of the batteries is still quite high. And we still have a little bit of work to do to bring that cost down of that sweeper to tell the customer that it is going to pay for itself. It's not there yet. But I do believe
moving pretty fast though.
Within a few years it'll get there.
Yeah. Okay.
And I can probably look them up after we're done with the presentation and tell you what I see. But the main thing that we found is that on the electric side, we have very little maintenance. Okay.
Right.
So if you go with electric, you're not really doing any, you don't have to do any depth work. You don't have to do any oils. You don't have any engine stuff to do. You don't have any of that maintenance. All you're focusing on is maintaining the sweeper itself. So, obviously, when it comes to hydrogen fuel cell, and that's not technology. That's a technology that's been around for a long time. So it is there. And when you look, one of the things that we always talk about is that if you look at a map of the US, and you literally divide it right through Wichita, and you go east, the power grid and the power infrastructure is immense. And we believe that part of the country, the East Coast, I would say, that will have, that will be mostly electric. The population is there. Everybody lives close to each other. Now, if you look at everything going west, now you're looking at distance. And now you're looking at covering vast amounts of this distance before you do anything at all in terms of fueling. So I think that's where hydrogen fuel cell is going to rule a little bit.
Hmm.
And so, but this is just kind of in our opinion. Obviously, time is going to tell.
Yeah,
But if you look at all the power plants and if you look at the available power and just the density of population, it is all on the east part of the country.
gotcha.
Um, yeah. When we designed that fuel cell sweeper, one of the things we wanted to do was it wasn't just to design a fuel cell. We were designing it to make sure we can, fully electrify it. But one of the cool things that we did with this machine that we found out a little bit later is that obviously when byproduct of a fuel cell street sweeper is water. Okay. And I know it isn't much, but in California, it could be a little bit more. They really try to conserve water in California. So we noticed that per shift, um, we actually generated an additional 43 gallons of water as a byproduct of running a fuel cell street sweeper. So we actually put that back into the water tank.
That's very sensible. One of the things that I've long thought is that we need an X Prize of some kind for the sweeping industry, is becoming more feasible now that it's been shown conclusively that street sweeping is the most cost-effective way to remove nitrogen and phosphorus per pound. It's considered
Yeah,
5 times more cost-effective than the next best technology of catch basin filters and so forth. But one of the things that I think is going to become increasingly important is that street sweepers use up hundreds of thousands of perfectly good drinking water every day and trundle that as kind of a PM10 slurry to the dump site. So, you're not only spoiling the water part and making it no longer available for drinking, but you're also having to get rid of weight when you dump it. There are just a lot of things bad for that. So if we can find two things, one is dust suppression without water, and the second is air and broom sweepers somehow combined, that technology will be a lot better off. That's for sure.
exactly. And I mean, you know what, the motors, the fuel cell motors are the engines, I would call them. They're improving. There's a lot of efficiency that still can be found there. And I mean, so I think we're at the cusp, we're at the beginning of that technology. There's no
Absolutely.
difference. Yep.
Yeah.
So more things are going to come, and yeah, and like you said, infrastructure is going to lead the way. So we have to have this infrastructure for the electric sweepers. We have to have the infrastructure in place for the hydrogen too, for
Mm.
any of this to work and to move us towards that other step. But so this next slide here is essentially our global M3 EV sweeper. This is pretty cool. We're using the same exact battery package that we use on our M4s. So one of the cool things about these products is whether you have an M3, M4, or M4 high side dump, on road or off road, piece of you know equipment, we use the same exact system for both, for all.
Hmm.
Okay. Um, and so that gives us standardization, and it gives us, the ability to just kind of study and work with the one system. Um, so another cool thing is every single machine has something called a self-diagnostic system. So as long as the customer can hook up to Wi-Fi, we can download that day's data and what everything has happened to the machine, and we can evaluate every electric component in that machine,
Wow, that's
starting from the
impressive.
charge. Yeah. And so we do that simply so that we don't have to, if something is wrong with the machine, all we need to know is essentially when it happened, if the customer can do that, what time it did, and we can literally evaluate every single component. So when we do replace anything, or if we have to ever replace anything, we just ship them that component. And the dealer will replace the component. We don't have him open anything, work on any high voltage lines. We keep everything at a minimum.
Excellent.
So the M4 sweepers, like I said, they were actually developed first. So when we're starting to build the machine, we use the M4 platform because it is an on-road platform, and it is a platform that is designed to go on highway, go for 55, 65 miles an hour. So we wanted to design that first because we knew that if we go to a three-wheel, which is off-road and its maximum 26 mile an hour speed isn't going to be a big deal. We knew we have a play, we knew we're going to be aiming higher, and we'll be able to achieve more. So we do build M4 low dumps and M4 rear dumps and high side dumps as well. So all of them essentially incorporate the same system. The M4s, they don't last as long as the M3s, about 7.5 hours total instead of about 10, in lieu of 10, just strictly because you can go faster. So we find that customers with these machines will do, they get up to 45, 55 miles an hour. And if you do that, obviously you use up more energy.
And I read on your
So, but
website that you're able to pick up an incredible amount of material with these machines. That's
yeah,
you want to touch on that?
that actually, when it came to electrification, the machines even became more efficient. So, back when we were, all of our machines are designed to pick up very heavy sand
mhm.
as we sell them and market them to California DOT. And California DOT requires that we pick up to 3 tons of sand a minute. And so with engines, with engine, we had to add stack of pumps to be able to achieve that. But we found that with the electric sweepers, because we're using the electric motor, well, the instant torque allows us to do that test very quickly. So the machines are actually more efficient as electric than they were as diesels. And we're still able to not only achieve these numbers, but they're actually even more powerful
Yeah, and
than the
that's something
diesels.
I wanted to bring up because I've heard, the diesel aficionados talk about how, oh, they don't know that electric is going to be powerful enough compared to what a diesel can do. But really, the opposite is appears to be true, and we've seen that with some of the tests of electric cars too. Their pickup is incredibly fast to get from 0 to 60, for example, and so forth. And the power just seems like that's not an issue at all. The time that the machine can stay operating, as you say, on an M4 is a little bit more of an issue, but the power is not. And I think that's a very important part to bring out is you can count on the power of the sweeping system as well, along with the propulsion system to do the job
Well,
to do.
exactly, but it's the cool thing is this: we designed the sweeper that has 210 kilowatt batteries, so we didn't go crazy with 300, 400 kilowatts. We did not start putting too many batteries on the machines. We designed a chassis that can handle just that same amount. We've managed to design that machine so it can last a whole shift, which means operator can run it from the morning and then finish the day and then still have just enough to wash the machine, do everything they need to do, park it and plug it in. And the cool thing about it, I think, is that we didn't change the chassis at all. We didn't make it longer. We didn't have to go beef up the suspension. Everything was designed for the same weight. But something that people don't think about is that we just begun. The battery technology is changing. We're getting calls from different manufacturers that are offering us more efficient battery systems that are lighter. Or give us the ability to put more on top and play with the weight factor. So I think as the technology is changing, these machines will become more efficient and they'll last longer and we'll be able to do all this. And then you add to it, a DC infrastructure where every city can actually plug in and charge very quickly. And now you actually have something that's very viable in the future.
Mm-hmm. Yeah, I agree. All right.
So
It's very exciting technology. It just is.
it is. It really is. It is. It's something that you talked about. Obviously, I don't know if you know, but on average, I believe the numbers are. I don't want to say anything, but a diesel engine, I believe, is about 12 to 15% efficient. Okay, which means everything that we put in the fuel, everything that we do, 15% of it is driving and doing what it needs to do. Everything else turns into heat and just
Over.
other energy. I believe the most efficient engine in the world is a Formula One engine, which is, I believe, around 50%.
Wow.
And then I think when people look at electrification, aside from the weight and everything else, that is roughly like 98% efficient, which means you're able to take all that power and actually use it where it needs to go.
Mm-hmm.
you
And
know, long
the
as,
analogy I'd use so people can understand that maybe easier is you remember when we had the old incandescent light bulbs and you
yes,
try to unscrew it and you'd burn your hand. And now you can take the LED lights because they're not producing a lot of heat. That's why the wattage is so much lower to have them give you the same amount of light. You can unscrew them with your hands because I mean lights shouldn't be made to produce heat any more than engines should be made to have all that overhead that's wasted, and you have all of the pollution added into that.
yeah,
So
exactly.
that's
Yeah.
very admirable.
Yeah, there's definitely, there's definitely a lot of advantages to it. Um, this is on that slide I'm showing you our newest creation. That was an M4 high side dump, which is something that is a class 7 chassis that is designed to dump to the side. Again, it is the same package. It is designed with 210 kilowatt a battery system that is supposed to last you a whole shift without any issues whatsoever. And it is currently in production and it is currently running with cities.
Hmm. And the hoppers
So
always look so clean when they're brand new, don't they?
they always do clean when they're brand new. That's it. That's about it. As soon as they go to work, it's over.
That's it.
Yeah. So, this is kind of the theory. I have a presentation here that shows you how our electric diesel sweepers worked, and essentially we had an engine that had a hydraulic pump that would control brake and steering. Then we had another hydrostatic pump that would control your driving system, and we had 2 or 3 pumps that were literally designed to run all of your hydraulics. That was your basic diesel infrastructure on our sweepers. We've always used one engine to control all the functions, and then we've always used hydrostatic systems on all our sweepers.
Hmm.
Now, on the electric, that changes completely. Now you have a high voltage battery right over here. That high voltage battery is, like I said, 210 kilowatt battery that goes into inverters. And then you've got one drive motor that's electric. And then you've got another electric small motor that also runs and just makes runs your hydraulic pumps, which in turn run all your sweeping components. Now, the cool thing that we've done is we've separated the system. So we actually have, I would say, a DC-DC, we call it a charger, but a system that constantly charges your 12-volt battery. So we have a 12-volt battery on that's always charged, like a regular car battery, and that pump is in charge of all your 12-volt systems, including your brakes and power steering.
Hmm.
So we're not really, all your lights, tail lights, headlights, most of your other functions, it's all still 12-volt based system. So we didn't change that part of the machine. All your relays, CAN bus controllers, nothing really changed. It still operates as your regular diesel machine. The
Okay.
only thing we changed is high voltage system to do the rest.
Yeah, that's a good system.
Yeah, so that's the kind of stuff here.
Yeah.
Like I said, we've got 2 water pumps. We're cooling the batteries. We've got an electric motor that drives in the back that drives the axle. We've got a beautiful display screen that shows you state of charge, how effective we are in terms of conserving the energy. It shows us the total voltage, if the batteries are on, your temperature for some of the components. We still have a radiator in the front that allows us to essentially um cool all of your electrical components. And then I know this is one of the questions that is often asked, but we had found that on average we're seeing about 15% efficiency loss from between 8 to 10 years of the battery life on these machines. So they lose a little bit. Well, we're trying to control how quickly we're charging them, how quickly we're discharging them, and make sure that they are not always discharged to zero, and
Hmm.
we don't allow them to be charged all the way up. So we're trying to control certain parameters in that system to make sure that we're actually taking care of our batteries.
Yeah, I've learned some of
Uh,
that now that I have an electric bicycle, and
mhm.
that's one of the things that I mean, if you want your battery to last longer and stay better, there's some parameters that you go with how far you discharge and then how far you charge up. So
Correct,
same
correct.
kind of thing.
Yep.
Uh,
So all
much
of that
longer
is
scale.
Yep, all of that is incorporated into our software.
Hmm.
And all of that is incorporated into essentially everything's done automatically for the operator. So it's nothing operator does. It's all done within the parameters of the machine itself, within the
That's good.
programming of it. So,
Yeah.
and then obviously we talked about the M3 operational time. We're seeing about 8 to 10 hours, so a little bit more than the shift. And then the M4 we're seeing about 7 to 8 hours, obviously depending on the operator and how heavy his foot is, and how quickly he
Yeah.
accelerates. People are very surprised, but you get into an M4, which weighs roughly 22,000 some pounds, and it takes off. So the electric part of it allows the machine to go very quickly. So now our biggest issue is how do we control that operator to slow down a little bit because he doesn't need to go that fast or he doesn't need to accelerate that fast.
Hmm.
That obviously is part of your conservation of energy.
Sure. That's always a challenge to. We used to say, in the old days, with parking lot sweepers, you have, $100,000 machine driven by a $12 an hour guy in the middle of the night with no supervision. What could
Yeah,
possibly go wrong?
yeah.
And the answer is lots. So the more you can automate that so that you're not worried about uh, the operator that's there on it, it makes a big difference. So pull this down to there.
Yep. Yep, and yep, I agree absolutely. And we think about the same stuff all the time. It's
Mhm.
exactly the whole point. Is how do you make the machine as simple as possible? This is the charging station. It's a Clipper Creek charging station. It's like I said, about an 80-watt system that it'll give you around 19.2 kilowatts max of charging. So you can do the math. We're at 210 kilowatt battery, so you're looking at about 11 to 12 hours, depending on the system itself, whether you have 208 to 240 volts and what's available to you at the building. Um, Otherwise, like I said, we work with Terra quite a bit these days. So they have available DC charging stations from 94 to 120 to 184 kilowatts.
Mhm.
Um, so depending on what kind of system you buy, that's also going to give you the amount, the ability of charging. So if you go with a 90 kilowatt continuous, you're still going to be somewhere around 2 hours to 2.5 hours, depending on how we control heat and everything else. But it gives you the ability to do a fast charge. If you have a 180 kilowatt charging station, you can actually try to charge the whole thing, or you can split it and you can have a dual station and you can charge two machines at 90. So there's obviously that technology is coming. And we use a CCS plug, so a combo plug again, so you can do both a DC charge, or you can do a 240-volt charge. You'll be able to do both.
Mhm.
Um, but this is what we do. And then honestly, the last presentation is just to kind of let you know that we're still constantly improving. We have some very high goals internally. We've done some really, really cool things. We're improving the way we load hoppers. We're doing some cool stuff in terms of load wheel designs and hopper access doors, and we're constantly working on better dirt shoes and it's simplifying the hydraulics, removing hoses, just a lot of things. And just recently, something that we have unveiled this year that's on the first machine that's going to be going on forward is something we call a diagnostic system, an onboard diagnostic system that essentially allows the operator or the service tech to diagnose every single sweeping component on the sweeper through a computer.
Mhm.
So it'll show you if the CAN bus controllers are working. It's going to show you whether you have a short or you have a break in the cable, and it's going to allow you to pretty much diagnose every sweeping function, everything from the water system to all of your gutter broom control functions, elevator functions, um, down pressure functions, everything by the engine. So because the engine has its own diagnostic system. So that's something that's coming on, that's going to be available in 2024. And we hope that's going to help customers literally, if there's a problem, just go into a computer, turn on the screen, and essentially just find the problem that they need. And it's going to have instructions how to fix it with part numbers right away. So everything that we're trying to do is just designed to make this machine simpler to use.
Sebastian, after going to trade shows for over 30 years and looking at all these different sweeper models and so forth, and especially, you peek into the hydraulics, your hydraulic or that whole system there was really clean looking. Can you go back to slides to where we just were? that. Look how clean that is. That's very beautiful. It looks well designed. It just looks good. Looks like you've done a great job of design with that. So
It
congratulations.
is, but we're still gonna push. We're still gonna push our partners and to do a little bit better. We would still like to have less hoses. We would still like to have a better comprehensive warranty on products. And our goal is truly to have this thing to be as to have the lowest total cost of operation out of anybody in the fleet. And so we still have to evaluate every single component and see if we're doing the right thing when it comes to this stuff. And we still have plenty of work to do, but I think we're getting closer. But I
Yeah.
think that's where things are at. I tell a lot of our customers that I don't believe they evaluate the sweepers once they get them. I think that a customer is going to buy a global and it's going to run great for 7 or 8 or 9 years, but the 10th year that it breaks down, well, that's what everybody evaluates the machine on. So if that machine was very expensive the last year of operation, my feeling is that they're going to look elsewhere to buy a different product. So you have to design a sweeper that can live for that 10 years and they can fix it and it's easier to repair and it's not too expensive to repair.
Mhm.
I think that's our end goal.
Good goal. I would think too. Well, thanks for the presentation. That was very illuminating. And one of the things that you see, and I know you picked particular sweepers to show and all that, but I've seen a lot of global sweepers, and they're just really nice lines. They look very clean. It just looks like you make a well-designed machine just for this application. You're not
Mhm.
putting a sweeper onto some kind of a standard production chassis. And what the consumer doesn't know is that the exhaust had to be moved, or whatever else had to happen with that chassis that was stretched by a third party vendor or something like that. So, and you're talking about your real emphasis about the minimizing your turning ratio, I think is also impressive, because that's one of the things that's so important with the sweeper is maneuverability, and you
Yes.
really emphasize that. So congratulations on that. Go ahead and if we're done with your screen share, then go ahead and stop that. And although that's probably better to look at, most people will agree, than both of our faces. Um, uh, and yeah, once that's stopped, there we go. Uh, what else would you like to say about global? I really appreciate the school lesson on not only global sweepers but on EV and hydrogen technology and where we're headed with that. And of course, we are moving at warp speed, as Captain Kirk would say, uh, on the whole higher technology issues like this. Um, Look at the differences that have been made since 2007 on battery technology, for example. It's becoming the holy grail of the vehicle industry. So, um, what else would you like to say before we conclude?
Honestly, not really much. Everything's changed. If you look at 2007 to now, people have different expectations now. Even customer cities have expectations. Market is very tough. People don't have as many mechanics. They want these machines to run longer. They keep them for longer periods of time, and they don't look kindly on any kind of a breakdown. Since COVID, the total cost of components has gone up drastically, in some cases 20-30%. So everything's become very expensive. And so, I think adjusting to this new world, it's very important, and you have to be swift at it because it's changing. Everything's changed in the last 5 years quite a bit.
Yeah, yeah, that's exactly right. Um, and let's 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 keep in mind where we came from here too. Let me see if I can share my screen for
Hmm.
a moment. Uh, if I can find here we go. It wasn't really it wasn't
Yeah.
really all that long ago, and that's what
Hmm.
we're looking at with the sweeper. The old Austin Westerns, they were just venerable and venerated by the sweeping industry, and there was tears shed, I'm sure, when they went down. But
Mhm.
look where we've gone to the sleek machines that you're selling today, and
Absolutely, absolutely. Back in the day, they didn't even have cabs. You just put on a mask, and you know what? And I appreciate that too. And so the street sweeper operators, they would put on white clothes and a mask, and they would go sweep without a cab or anything else in that dust. And it was, it was normal. Now we have to have AC, air ride seats, Bluetooth radios just to be able to get in a piece of equipment. So just think about all that in the grand, scheme of things.
yeah, yeah, that's exactly right. Back when I first started and represented the Schwartz family, we had a situation where they bid, and I won't say what city, even though I still remember, um, and they lost. It was 5,000. They were $5,000 less expensive than the competitor who got the
Mhm.
bid, and the public works director said, "No, we just think it's a lot better sweeper and all that." And the operator said, "Yeah, we like this a lot better." And so that's what they bought. And
Mhm.
I think it was more than one sweeper that was purchased. And only after that, I got back to, and what they asked me to do was send a letter to the city council. And I sent a letter to all the city council people. We FedExed them overnight the day of the bid opening. And they said, were you sure we need to buy something for $5,000 more? Oh, yes. Public Works Director said, yes, we do. And so they did. But come to find out, the difference was that one of the chassis had a cup holder, one didn't,
Yeah.
and
Yeah.
that was worth $5,000. Was the
Yeah.
operators wanted that cup holder? So
Yeah.
there are those little things that are out there, and we're changing rapidly with all of this technology. And I really appreciate that Global is really at the forefront of bringing this zero emissions technology to the American marketplace and more. So congratulations to you for
Thank
that.
you. Thank you. And you as well, growing the WorldSweeper brand. I mean, that's it's pretty, interesting how many, people go and read your stuff now. I talk to our counterparts in Germany and they tell me they read that stuff every month.
Uh, they do, maybe
So,
more than the Americans do sometimes. But
yeah, maybe.
yeah, water quality is really huge, and that's where we're headed. I'll be part of a study that's coming up with the University of Santa Barbara, and we're designing what sweeper models are best for removing microplastics, and that's such an issue that it's just it's a tough one. It's a real tough issue to get the big stuff and to get the very small stuff too. So anyway, that's where it's all headed, and I'd sure like to see an association of sweeper manufacturers all get together and throw some money in a pot and together and go out to the stormwater community and really talk about what sweeping can do, because it doesn't get we go back to the Martin Luther King quote about, if you're going to be a street sweeper, which is that lowly occupation, then, you've got to be the best street sweeper you can. Well, the fact of the matter is street sweeping is the first line of defense on being 5 times better than the next technology for removing material off the street, pollutants, nitrogen and phosphorus, the big ones. So come on, let's get sweeping what it needs in terms of the credit and the reputation and so forth. So I appreciate
Absolutely.
you're one of the people in the forefront of doing that and showing what sweeping could do as zero emissions and so forth. And you seem like a wave of the future to me. So
Well, thank you so much for your time as well.
yeah. Well, thanks, and we'll I look forward to seeing what's next on the horizon with Global. Thank you.
Yeah. Thank you, Ranger. Okay. Bye-bye.
And I can't